So a while ago, Anthropic published an article called Building Effective Agents, where in it they discuss about their experiences and findings building agentic frameworks for their clients. So after working with dozens of teams across industries for over a year, Anthropic discovered some agentic frameworks that are effective in production and shares them with us in the article. And upon reading it, I realized just how valuable the insights really were, because after all, they were sharing with us what they had learned building agents in production for over a year. So I figured this is definitely not something we should take for granted, but actually dig into. And because of that, I decided to fully grasp these concepts by implementing the workflow blueprints from the article as practical examples in n8n. And in this video, I'm going to walk you through each of the workflows step by step so that you can understand them too. If you're interested in building agentic frameworks, then understanding each of the workflow patterns is crucial to making the right design choices when building these systems. So I would definitely recommend you to master them. And by the way, the article also discusses the distinction between workflows and agents, which is an important concept that we will explore in more detail after we've gone through the practical examples to ensure that it fully clicks. So stay tuned for that as well. And without further ado, let's just get started. All right, so before we start, I'd like to let you know that I'm going to be uploading this template to my Skool community business AI Alliance, which is entirely free. So feel free to join to get access to the resources shown in this video and in my previous videos. And with that said, let's go to the first example, which is going to be prompt chaining. Let's take a look at what this is. So prompt chaining decomposes a task into a sequence of steps where each LLM call processes the output of the previous one, which is exactly what's going on in the diagram below, right? We can see there are 3 LLMs that's processing different parts of a particular task. We have LLM call 1 processing the first part of the task, generating an output. The LLM call 2 uses this output to process and complete the second part of that task and then generates an output, which is then used by the LLM call 3 to process the final part of that task to finally generate a response. So when to use this workflow? This workflow is ideal for situations where the task can be easily and cleanly decomposed into fixed subtasks. The main goal is to trade off latency for higher accuracy by making each LLM call an easier task. So we are trading off latency because we are adding 3 LLM calls instead of 1, but with that we are getting higher accuracy, right? Which is what we would want in most cases. So the core idea behind prompt chaining is to break down a larger complex task into manageable steps that can be handled by multiple LLMs. This way, instead of loading all the responsibilities on one LLM, each part is handled more effectively. Let's actually take a look at an example that I created for this blueprint here. In this example, we are going to create a report based on a given topic. Okay, I've decided to break down the task into 3 separate parts. In the first part, we are going to generate key points and angle for that given topic, list concise structured key points and angles about the following topic, and then we are going to use these points and angles to pass it to our report planner, who is then going to use this as a reference to create the outline of the report. So it's going to be able to use this and come out with a more cohesive outline for the report that we want to create. We have the introduction, right? We pass it the main body sections, which is what it's going to also include based on the notes up here. And then we are going to have a conclusion. For each of these sections, it's also going to include brief descriptions, by the way. And once we have the outline of the report, we are going to pass it to our report generator, which is then going to generate this report based on the given outline by our report planner. Let's take a look at this in action. By the way, before that, once we get the output, once we get the output, we're going to send it to me on Gmail so that we can see the result. And for the input, by the way, I'm just using a set field so that we can save time, right? So we have the topic here, and the topic we're going to be researching on is obesity. And without further ado, let's just actually test this workflow now. I'm going to click on test workflow, right? We started processing it. We are generating the key points. And to do this, as you can see, we are using separate models, by the way, just to show how much more flexible it can get, where we can decide which model to use in each section, right? We got our key points generated. So these are our key points and angles. We passed it to our report planner, which is now going to use this as a reference to come up with the outline of the report. And then we pass that to our report generator, which is now going to use the outline of the report to actually generate the actual report. And we are waiting for that to complete. And once it's done, it's going to send us an email and we're going to take a look at the result. All right, we received the email. Let's take a look at what it looks like. All right, so this is the report it generated for us. Comprehensive report on obesity. We have the introduction as specified in the report planner. Then the main body. This is what the main body is made of, right? And then finally, we have a conclusion section. And with that, we have our report. So going back to the canvas, we saw how we were able to split this task into subtasks and assign them to separate LLMs, which work together to come up with the report we just saw. Another benefit to prompt chaining, apart from the higher accuracy and the flexibility, is the ease of debugging. If we had this whole task done by a single LLM, if an issue occurs within it, we would not know which part of the prompt is causing the issue, right? So if we would have to take a look harder, we'll probably fix something that's not already broken. But in this case, because we've broken it down into subtasks, we can see exactly which part of it is causing the issue and just fix the LLM that actually has the issue. So you can imagine how much easier this makes our jobs, right? With that, we have prompt chaining out of the way. Now let's look at the second example, which is routing. All right, so routing classifies an input and directs it to a specialized follow-up task. This workflow allows for separation of concerns and building more specialized prompt. Without this workflow, optimizing for one kind of input can hurt performance on others. This is actually super simple to understand, right? And it is exactly the same idea as prompt chaining, where we are trying to minimize the scope of responsibility given to a single LLM. Let's imagine that you want to create a system where you can manage your Gmail, your calendar, or your Slack, right? In that case, you don't want to dump all of these responsibilities and all these tools into just a single LLM, but instead create specialized agents for each of those platforms, right? One for your calendar, one for your Gmail, and one for your Slack. That way we are able to minimize the responsibility a single LLM has, so that we can also create more focused prompts. So based on this diagram, in that case, if we wanted to do something about our Gmail, for example, get my last emails, we would pass our input and the classifier LLM is going to decide what kind of request it is, and based on that, it's going to route the workflow, right? In our case, we want it to be Gmail, so it's going to pass it to the Gmail LLM, and then the LLM is going to process our request and respond to it. And that's pretty much it, really, right? So let's take a look at an example I created for this, which is super simple. So we have a bunch of agents that are specialized in different things. One of them is specialized in generating poems. The other one is specialized in generating jokes. And finally, we have one that's specialized in generating stories, right? And we also have another route where it's not clear what exactly the user wants to do. So we have our input. In this case, it's tell me a joke about a cat. Okay, about a cat. And then we pass our input to our text classifier. Within this text classifier, we created categories, right? It's going to classify the text and figure out what the user exactly wants. It could be a poem, a joke, story, or where again it's not clear what kind of content the user wants, right? So I'm expecting it to route us to the joke generator. Without further ado, let's start with the example. Let's test it out. I'm gonna remove this manual trigger from here and attach it to this workflow. Okay, I have this ready. Now I'm gonna refresh the test and click on test workflow, and let's see what happens. So exactly what we expected happened, right? We pass in our input to the text classifier. The text classifier figured that the user wants a joke, and then it routes the workflow to the joke generator. The joke generator gets it and generates a joke for us. Sure, here's one. Why did the cat sit on the computer? Because it wanted to keep an eye on the mouse, for example, right? So that is exactly what routing is. And of course, this is a very simple example, but imagine a scenario where we had actual complicated tasks that may require detailed prompts and even multiple steps of actions to complete. That is where this pattern truly shines. And with that, we are done with routing. Now let's move on to our next example, which is parallelization. All right, so parallelization. LLMs can sometimes work simultaneously on a task and have their outputs aggregated programmatically. This workflow parallelization manifests in two key variations, which we'll actually be seeing both in a bit. As you can see, this is called sectioning, and then this is called voting, right? Let's take a look at their descriptions. So sectioning is breaking a task into independent subtasks that run in parallel, and voting is running the same task multiple times to get diverse outputs. So let's take a look at the first example here, which is sectioning. I'm just gonna go ahead again and remove this trigger and attach it to this workflow. Right, and here we are going to be testing out sectioning. In this scenario, what we have is we have a sort of travel agent, right? We'll tell it where we want to go. So for instance, Taksim Istanbul, we'll give it a location somewhere in the world, and it's going to take that and find us restaurants, hotels, and activities. To make this more detailed, I actually attached SERP API, which is a browsing tool. So it's going to be able to look for these things in real time and actually give us accurate data, right? So we got restaurant finder with this simple prompt here, right? It's going to find us 5 restaurants. And then we have hotel finder. Our hotel finder is also going to do the same thing, but it's going to be looking for hotels. And then we're going to have activity finder, which is also going to be doing the same thing, just finding activities. So what's going to happen is when we pass in our location, they're going to run in parallel, and then once they're all done, we're going to merge their outputs here, okay, and we're going to aggregate them and send it to us through email, and we'll look at what result we come up with. So we can see that we're going to get the hotel recommendations, restaurant recommendations, activity recommendations. So let's actually quickly test this out now. I am going to click on test workflow, but before that, let me click on reset. Another thing before we start testing this is that due to the limitations in n8n, we are not able to actually run this in parallel this way. There is a workaround, but it's too complicated for me to include into this video, which is supposed to be beginner friendly. But at least this way we are still able to follow the same concept, right? The idea is the same, just without the parallel part. So with that out of the way, I'm going to click on test workflow, and we are passing in our location, right? We're telling it Taksim Istanbul. We can see that now our first LLM is looking for restaurants. And for this, it actually hit the SERP API to get the Google results. We are done with finding restaurants, and now we are looking for hotels, right? Or the LLM is looking, the second LLM is looking for the hotels for us, and done with that as well. And finally, we are looking for activities that we can do in Taksim Istanbul. All right, so all 3 is done. We got all of the outputs and we merged it and finally aggregated it. Then we formatted the response and sent it to me on email. All right, so here is our email. We got the hotel recommendations, the restaurant recommendations, and activity recommendations. Basically, each of these aspects were taken care of by separate LLMs, and we got all of the responses merged together, formatted, and then sent us to email. And that's exactly what sectioning is and how it works. So now let's take a look at the second variation of parallelization, which is voting. I'm going to attach this to this workflow here this time and reset the test. Okay, so let's first remember what voting was. It's running the same task multiple times to get diverse outputs. So what we have here in our example is we have a copywriter system, okay, that's going to do this. You are a creative copywriter. The user wants 3 catchy slogans for their brand or product. Emphasize originality, memorability, and brand appeal in each slogan. Do not include any extraneous details or explanations. We got the same exact prompt in all these 3 LLMs, but if you notice, the models attached to each of them are different, which is going to further help with the diverse outputs. Once we have all the responses, we are going to merge them, right? We are going to do it with this node here, and then further aggregate them and format them into a text that we can read, so we can understand which model which were generated from which model. And finally, we'll send it to us on Gmail. So without further ado, let's actually get started, right? Let's first take a look at the input, which is AI Athletic, an AI-driven fitness app that will personalize exercises based on user profiles, right? So we are going to create a combination of slogan for our app here, and let's get started. I'm just gonna click on test workflow for this, and there we go. All right, so we got all the responses ready and it sent us an email, but I just noticed that I misplaced the models. As you can see, I wrote OpenAI here, but attached it Google's Gemini, and for Gemini, I attached O3 Mini, which is a mistake. Sorry about that. But let's now go take a look at the email and see what we got. All right, so this is the email, and as you can see, we got 3 different versions of output from the same input, and this is exactly what the voting variation of the parallelization is. And with that, we are done with parallelization, and we can move on with our next example, the Orchestrator-Workers pattern. All right, so in the Orchestrator-Workers workflow, a central LLM dynamically breaks down tasks, delegates them to worker LLMs, and synthesizes their results. And when you look at the diagram, if you notice, it's kind of similar to the one we have in parallelization, right? And this actually also involves running LLMs parallelly to complete a certain task. But the only difference is that in this case, we added the flexibility of choosing how many of them to run for a particular task. For instance, in the example we had here, our execution guaranteed to run all these 3 LLMs where we'll always look for restaurants, hotels, and activities, right? But if we were to implement this example using the Orchestrator-Workers workflow pattern, what we could have done was we could have given the user the flexibility to decide which of these 3 they would like to research about, right? For instance, they could decide to go just with restaurant, or just with activity, or activity with hotel, or all of them together, or even none of them. So that is the beauty of the Orchestrator-Workers workflow pattern, and honestly, I'm really in love with it. It just allows us to create a very flexible and dynamic system. We're actually going to be taking a look at an example that I created, which is about a different scenario so that we can see more diverse use cases. So to test this, I'm going to remove this trigger from the previous workflow and attach this to this workflow here. And I'm going to again reset it, right? And now we are going to start. But before we do, let me explain to you what this scenario is. So we have an orchestrator agent, as we can see in the diagram, and let's take a look at the prompt of this orchestrator. You're an orchestrator. A user will provide a text and the language or languages they want to translate the text into. Your goal is to identify all the languages the user wants to translate the text into, identify the text, right? Produce a valid JSON array where each element has a language field and a text field. And then the constraints are outputs only JSON, nothing else. If multiple languages are listed, create 1 object per language. If no languages are mentioned, output an empty array. All right. So our expected output is going to be something like this, where we got the text, right? The text will always be the same. And the languages that the user wants a particular text to be translated into. Let's actually take a look at our input before we start this. Okay, so we got our orchestrator input created using a set node. So our input says, please translate the following to Spanish, Turkish, and French. And this is the text we want to actually get translated. All right. And then we have a translator agent. This one is really straightforward, right? It's just going to translate the text to the given language. And so overall, what's going to happen is we are going to pass in the input. The orchestrator agent is going to receive this input. And then based on that, it's going to generate a structured output similar to this one here. It's going to generate arrays of languages and text we want to translate the text into. Okay, and then we're going to split out that response so that we can create an array out of a direct array out of it instead of an array nested in an object. And we will then run this translator agent once per item in the array, and we are going to be doing it parallelly, and then we are going to aggregate the text and finally send it to us in email. All right, so let's actually test this out real quick. I'm going to click on test workflow, right? In our case, I think we have like 3 languages, no? Spanish, Turkish, and French, right? So we'll expect it to output 3 items, as you can see. So we got 3 items output, Spanish, and then the text here, right? Spanish, Turkish, French. And then finally, we are running the translator agent 3 times parallelly to generate the desired output. Now we got the whole thing sent to us through email. So let's take a look at it. All right, so we got the email and the translated text. As you can see, we got it translated into 3 different versions and got them sent to us on Gmail. So that is the idea of the orchestrator workers workflow pattern, right? Before the input, the orchestrator didn't know how many subtasks to create. So instead of having 3 languages that we wanted it to be translated into, we could have also given it 10, 15, right? Based on that, we are going to actually run that many agents or LLMs parallelly. By the way, I accidentally mistakenly called this an agent, but these are LLMs, even though we are using the agents node, but we are using them as simple augmented LLMs, right? And we're going to be talking about this, like as I mentioned earlier, at the end of the video. Once we are done going through the examples, we will understand the difference between a workflow and an agent. But anyway, that was the orchestrator workers pattern. Now let's move on to the next one, which is the Evaluator-Optimizer, which I think is super cool. All right, so the Evaluator-Optimizer is super simple to understand, but it's also super effective, especially when used in right places. So let's take a look at the description. In the Evaluator-Optimizer workflow, one LLM call generates a response, while another provides evaluation and feedback in a loop, right? We can take a look in the diagram. We have an input, and then the input goes to the first LLM, which is the generator LLM, right? It generates an output. Then the second LLM evaluates this output based on a given criteria and determine whether or not the output meets the criteria. And if it does not, is going to reject the request and provide this LLM with a feedback on what's missing so that it can reflect on it and generate its next output accordingly, right? And this loop is going to continue until the evaluator accepts the output, in which case is going to proceed with the workflow. Take a look at when to use this workflow. This workflow is particularly effective when we have clear evaluation criteria and when iterative refinement provides measurable value. The two signs of good fit are, first, that LLM responses can be demonstrably improved when a human articulates their feedback, and second, that the LLM can provide such feedback. This is analogous to the iterative writing process a human writer might go through when producing a polished document, right? Let's actually take a look at an example that I've created here, which is an email-based customer support system. So we'll receive an email, right? And then we'll have an email classifier that's going to determine whether or not this email is a customer inquiry or whether it's not, in which case it's going to output as no action required and not do anything, right? So we have a customer support LLM that is going to represent this LLM call generator. And then we have our evaluator LLM that's going to evaluate the customer support email response, and if it accepts it, it's going to proceed with the workflow and end up sending the email. But if it does not accept it and rejects it, it is going to provide a feedback which is going to be passed to this feedback and later passed back to the customer support to reflect on and refine its output. So let's take a look at the example, right? So we have the classify email here. We already looked at it. We have two categories: customer inquiry, no action required. In the case that this email is a customer inquiry email, we'll go to our customer support and we'll pass in the email content as the user message. And then we have a system message down here where we provided with some instructions, right? You're a customer support specialist at Tech Spark Solutions. And you can see there's another section here that's called feedback and prepared email. This is going to be empty in the first run simply because there won't be a feedback in the first run, right? We'll take a look when this is actually going to be populated. So the customer support outputs a email response, which is going to be forwarded to the evaluator. The evaluator is going to observe this email content that's generated by our customer support, and this too has its system message where it's going to evaluate the email based on the clarity and completeness, tone, professional friendly, etc., and to sign off as John Doe, which by the way I purposefully excluded from the customer support LLM so that we can see this workflow pattern in action. So I would expect our evaluator to at the very least to provide a feedback on this in the first run. Apart from that, we just tell it to output its response in a structured manner, right? We have two fields, pass and feedback. If pass is true, we don't need any feedback. If pass is false, and we also provide it with feedback. So then we have this if node here that's going to check whether or not it's a pass. If it's a fail, we're going to go to this node here, and in this node we are going to have the current email that this customer support generated, and then the feedback provided by our evaluator, and finally the text, which is the email of the customer, right? All this information is going to be passed to our customer support LLM, and this time it's going to have the feedback present, in which now it can use it to refine its output and output accordingly, and the cycle will continue until our evaluator accepts the email and finally the email gets sent back to the customer. So without further ado, let's test this workflow and see what happens. All right, so I have this email prepared, which is going to be sent to this email, which represents the customer support, right? The subject is operational hours, and the content is, are you open on Sunday? And what are your operational hours? So I'm going to click on send. Once I'm done clicking on send, we're going to go back to our canvas and then click on the email trigger and see this baby in action. Okay, I'm going to click on test workflow now, and let's see what happens. So we are classifying the email. It's supposed to hit the customer inquiry, right? That's exactly what happened. Our customer support created a response, right? And now our evaluator decided that it's not correct, and it provided a feedback, and finally we got the email sent. So let's take a look at what happened. So going to the customer support, let's take a look at the first run, right? So the text contains subject, and we can't see any sign off as John Doe, right? So we hit the evaluator. The evaluator gets this input, okay? And the first output was remove the subject line from the email content and update the sign off to John Doe instead of using a placeholder, which is perfect, exactly what we wanted. So we go back to our customer support again and take a look at the second output. This time you can see that we don't have the subject line and we are signing off as John Doe, which is exactly what we wanted. And with that, our evaluator accepted this and proceeded with the workflow. And finally, we received an email. So let's take a look at the email. All right, so this is the response. As you can see, we don't have the subject line on top. And then Finally, we did sign off with John Doe. Apart from that, the body, it came up with some fictional operational hours. And with that, we were actually able to see how we utilize Evaluator and Optimizer pattern to ensure that the email met the specified criteria, and it did exactly that. And with this, we are done with Evaluator-Optimizer, and we're going to move on with the next design pattern, the agents. All right, so now we are at agents, and by this point we already know what exactly an agent is, right? It's an LLM. It's a framework where we can provide it with tools and a memory and then an LLM to connect to it as a brain. And with that, we can tell it what we need, and it's going to decide on the steps to take and the tools to use in order to complete our request. But what exactly is the difference between an agent and the workflows that we see above here? The difference is that none of these were actually agents. Even though I used the agent node here, we didn't use them as agents, but we used them as augmented LLMs that has access to tools, right? Apart from that, what they had to do was clear. They didn't have any kind of agency or autonomy in the decision they wanted to make other than the request they generated. So what makes them different then? So if you notice, with our agent, there are no predefined steps. We just provided with the tools we want. Here we have a calendar agent who has access to a Gmail tool and calendar tools, right? So I'm able to tell it to, for instance, create a calendar event for me with this person and send them an email to inform them about this event. And it's going to be up to the agent to decide which actions to take in order to do that. It might decide to first send the email, or it might decide to first create a calendar event and then send the email, right? But if you notice, with the other patterns that we see here, we actually have predetermined steps, right? Where the steps that should be taken in order to complete something is clear. For instance, we had this travel agent system where we were provided with an input, and it would guarantee to pass through this stage of the workflow and then merge the item and then aggregate it and then send us an email. Or when we look at this Orchestrator-Workers workflow here, we first get the input, then we pass it to the orchestrator agent. Again, I mistakenly called it an agent. It's the LLM, right? It outputs the arrays for us. Then we split it out. We decide to split it out again. It splits out and then passes it to the translator LLM and then aggregates the translated text and sends it to the Gmail. Again, the workflow is determined, right? We determine the steps that should be taken. The difference is that with agents, these are not predefined, and it's up to the agent to decide the course of action in order to complete a particular task. So that's exactly what the difference is. Knowing this difference, we can now make an important design decision when building these systems, right? A good rule of thumb to follow is, if the task involves repetitive, well-defined steps and predictable outcomes, then use a fixed workflow like the ones we have above. And for cases where the task is complex, dynamic, requires decision making and adaptation, then definitely go with AI agents. And with this out of the way, we are now done with the videos. We went through all of the patterns that were shown in the article by Anthropic, and yeah, it was really cool to learn, and it was also really fun to film this video. I hope you enjoyed it as much as I enjoyed filming this video, and I hope that this adds a lot of value to you as a developer of these systems. And to iterate what I said at the beginning of the video, I'm going to be uploading this template here to my Skool community, and it's completely free. So again, feel free to join to get access to the resources shown in all of my videos. And with that, have a great day, guys. Take care. Peace out.